Howdy, y'all.
Hey, Elasticians, welcome back. The topic of the video today is investigating long-running node tasks.
Yeah, yeah.
So let's get into it a little bit. So a backlogged or backed up task queue can prevent tasks from completing, leading to an unhealthy cluster state, which we hate. The perfect storm of factors include resource constraints, a large number of tasks triggered at once, and long-running tasks.
Yeah.
So let's take a deeper look at this. In general, long-running tasks frequently relate to search and ingest events, and today our example is related to ingest events specifically.
Yeah, yeah.
So handing it off to Steph for the live example and cached example.
Yeah. So same as our other videos, we spun up an Elastic Cloud. This one is on version 9, bright and shiny. But showing an ingest event, it's really hard to break a cluster live. So I did what I could, but we're still just going to have to show you some examples on the side. So in order to prepare for this, we ended up setting up a long-running script that's going to cause write events to take a little bit longer. We created a test index and we connected those two so that each ingesting event passes through that default script. We also enabled slow logs so that we can show you a comparison later. So this is running in the background. I have a script that's doing ingest events. Here you'll see when I'm pulling cat tasks, I don't see ingest events. So again, those are processing through the cluster extremely fast. Um, every so often though, you'll see a blip that is actually showing us that ingest event. Uh, in particular, if we just go into ingest events somewhere in here, I'll blip, be able to show you that event. So again, search engines are optimized. They're great. They handle high volume. Therefore, it's hard for me to show you an example. But from our test index, as we pull, we can see that those doc counts are incrementing over time. So when we have cat tasks, as that doc ends up explaining, we're going to use the task management API, um, which is going to emit the different write events for us to investigate. So here it's going to emit nodes. It's going to have node information like its roles and its attributes. And then underneath it's going to have our tasks. So from what I cached, let's show you a couple of examples. So over here, node into tasks, and then each individual task is going to have an action, is going to have a description, and then it's going to have a running time. So the couple of examples we're going to discuss today so that y'all can see are if I'm doing individual write requests to my index, which again is not recommended. We recommend you do bulk tasks. Uh, in the description, it's going to tell us the ingest target, and then under source, it's going to tell us the request body. So right here, we have a huge lorem ipsum telling us the request body that's currently ingesting. And then running time tells us that it's taking 717 milliseconds or microseconds. So that is exactly why I can't show you live, but I can show you in a cache. Very same spirit, if we were ingesting large request bodies, still an individual write, that request body is no longer going to show just to keep the task management API responsive. And instead, it'll just kind of tell you the general size of the document you're attempting to ingest. So that's what individual write requests look like. Very similar spirit. So for searches, the multiple at once would be called an M search. For ingest, multiple at once is called bulk. A bulk request over here will tell you in the description, it'll tell you the number of documents inside of that bulk request. Client side, that's known as your bulk size. And then it'll tell you your ingest target, which may be one or more target indices. And then this also tells me running time is still only 16 milliseconds, so also extremely fast. All of the examples we did for our test, we did not set up the Elastic's recommended headers, but we do want to show a couple of examples to show. Down here we have our logs and metrics is ingesting bulk size of 50 into the Elasticsearch or Elastic Cloud Monitoring Index. Under here, it's going to tell you its header with an X Elastic product origin of beats. So very same spirit when Kibana is syncing to its Kibana Analytics Index. Here under the headers, we can see This X opaque ID for Kibana ends up telling you that the Kibana server under the Discover tab has a lens trying to store analytics about its histogram lens. So at that point, we can kind of see when we're trying to investigate our tasks, in particular, if our tasks are inducing something like rejected requests, whether that's thread pool backing up, whether that's circuit breakers due to large request bodies, or whether that's indexing pressure related to bulk size and or large docs. Any one of those three situations that comes up, we very frequently directly go to the task queue in order to see what's happening. But again, it's a little hard to actually show you this problem live. So every time
Really
I'm
good
pulling,
problem.
yes, it's a great problem to not have the problem, right? So us trying to show you live is having some difficulty showing. So we just wanted to say, very same spirit of Annie's earlier video, when you're not live for the problem, you might set up slow logs in order to show yourself very similar content. So just confirming under reading and writing documents, it's going to show you very similar, but not par. So up here, the task management is showing kind of that network data node level that says the node has received a task that it needs to process, versus slow logs is showing more down towards the storage layer that says, and as the shard is actually going to write to disk, what different information is emitting there. So let's show you some slow logs just to cross compare to the node task examples we just showed.
So because we enabled slow logs, we want to look at wherever your monitoring data is ingesting. You'll see in the log output, Stef Nestor is ingesting into the target index test. The slow log took is the response time it took. It did not take very long, very small, very fast. And then the slow log source is showing the actual response body of the doc, which is going to give you a bunch of information.
Yep, perfect.
Woo!
So at this point, if you're not live for it, just confirming, slow logs tells you very similar. But in particular, if you are live for a problem, this description column and the running time as core parts of those task queue backlogs really help you identify, in general, when you have task queue backlog, which part you need to investigate further and or modify. So with that, we did it. That's how you read node tasks.
Done. Thanks for stopping in. We're always happy to see you.
Yeah, thanks everybody.
Bye.